All right, so what is an array? It's a variable that can store multiple values of the same type. Now, if you took one of the Python courses, you call them lists. Now, lists are actually not arrays, but they can be used as arrays. The difference being is that array is fixed in length. So once you allocate the array, that's it. You can't start appending more values to it. It's just you make something that's 10 items long, that's it. It's not going to ever become 9 or 11 unless you create a new array of the new length and then copy all the elements that you want into it, which is kind of annoying. So an array is fixed in length. Also, arrays are stored in adjacent memory locations, which makes it really easy for the compiler to create the code that accesses them. So arrays are faster data structures than lists. And here, C++ is calling them vectors, but there are list structures as well in C++, but the one that this chapter demonstrates is a vector. Same thing, you create a vector and you can append items to it and it grows and shrinks dynamically, whereas an array is fixed in length. However, since it's growing and shrinking dynamically, it doesn't know when it's created how much data it needs, and so it can't create all the elements contiguously. So if you have an array, right, and say this was stored at byte 1000, then the next one is going to be stored at byte 104. How do I know that it's a byte 104? Because it's a 4-byte data type. INT is a 4-byte data type. And then this one is at 108, and this one is at 1012, and this one is at 1016, and so on. So the first element is that one, the second one is that one, and so on. They are named by their index number, their subscript, two synonymous terms, right? So this would be test subscript 0. This is test subscript 1, test subscript 2, test subscript 3, and test subscript 4. So int is the data type of the array. If you ever take Java, you're going to see that a difference is that when you create an array in Java, you put the braces here rather than over there. Java just had to be different. Then you give it a variable name. All of the elements in the array are accessed through the same name. You could have 10,000 test scores, but they're all called tests, right? You don't have test score 1, test score 2, test score 3. Instead, you have tests subscript, 0 or 1 or 2 or 3. This is known as a size declarator. It's not strictly necessary. There are times when you can leave it out. But if you put it in, then you get an array of that size. You get room in memory enough to store 5 integers. And so the size of the array, although people will call that the size because it's called the size declarator, it's actually the length. This is the length of the array. And the size of the array is the number of bytes, which is the number of elements, the length of it times the size of each element. So for a double, an array of doubles, each element is 8. And so it would be 5 times 8 is 40 bytes long. That's its size, but its length would still be 5. So just as it said, I guess we have to have another slide here that says the same exact thing. The size of the array is the total number of bytes allocated for it, which is the number of elements, the length of the array times the number of bytes for each element. Now, C++ is annoying because it does not give you a way to ask the array for its length. Unlike Java, where you can just call array name.length and it tells you, okay, I've got 5 elements in me. Or in Python, you call len parentheses list name and it tells you I've got 5 items in it. C++ didn't do that. So there are other ways of calculating the length, but they don't all work. Well, and specifically, they don't work in every context. You can calculate the size of the array and divide it by the size of the number of bytes for each element. So if it was, 40 bytes was the size of the array, and then each one took 4 bytes, 40 divided by 4 is 10. Now you know how long the array is. But that only works when you're in the same context in which the array was allocated, if you're within the same pair of parentheses, right, the same function. So usually, to get around that, you create a constant that's got a variable that represents the size of the array. And then whenever you need to, like in a for loop or a while loop or something, when you need to refer to the size of the array, you can just refer to that variable. Also makes it easy to change. Later on, you decide you need 10 integers. You can edit that to 10, and then the rest of your code starts working. So accessing array elements, just like I mentioned, 0, 1, 2, 3, 4, and each one could have a different test score in it, right? That one's a 90, and then they earned 100, and so on. And so if you want to get a hold of one of those guys, I am not good enough at Excel, excuse me, PowerPoint to be able to insert text just on the fly. Fine, forget it. Anyways, if you wanted to get a hold of that first element, you would do test subscript 0, and that gives you 90, right? And then test subscript 1 would give you 100. Test subscript 2, test subscript 3, test subscript 4. And if the element was declared with a size declarator 5, that's it. You better not go any farther, right? Because that's all the memory that was allocated. And if you try to access element 5, then you're off here and you're off reading unallocated memory, which could crash your program, or at the very least give it, bad results, indeterminate results. You don't know whether it's going to crash or not. Just certainly won't be good data. So if the first element is 0, the last element is n-1, where n is the number of elements in the array. Our test array was allocated as 5, so we can access elements 0 through 4. And any array element can be used as a regular variable of the same type, right? So we can store, just like you could normally do I is equal to 79. Well, that element is an int, so you can store 79 into it. Just like you can normally print out t if it's an integer or whatever, you could just as easily print out that array element because it's also an integer. Want to read data into it with CIN? Great. You want to add 2 of these integers together and store them in a third integer? You can do that. But you access them by their individual elements. You can't just say cout tests and it'll print the entire array. Works in Python with lists, doesn't work in this language with arrays, right? So you got to see them out. You got to see out them one by one, like with a for loop. Might not be a bad time to go ahead and create. Lecture S, perhaps. What, did I never move it up? Yeah, I never moved it up. So R. I'm just going to make this one week 13 and 14. Alrighty, there we go. Okay, so we're on Lecture S. New console app. I don't care. All right. So an array of 5 scores. Int tests 5. If we try to print out those tests, let's see what we get. We have not stored any data in them, so it'd be a miracle if there was some data. But hey, maybe it initializes them all with 0, like it does in Java. You can tell from my dubious tone that that's not going to work. So we could see them out individually, like this, with 0 and 1 and 2 and so on. Better put using namespace std there if we're going to do that. Now you can tell that a loop would be a better way to handle it, right? Because if this was 50 long, I would not want to copy and paste that 50 times. And there they are. I forgot to put some ENDLs, but you can tell that those definitely are not zeros. That particular value is a value that compiling it for debug caused Microsoft to store in it. It's a very distinctive value that anytime you access an uninitialized array, remember, you'll see that number and you go, oh, well, I access an uninitialized. If you compile it for release, see how I did that? I went up here and I said, I want a release version instead that strips out the debug code, makes it run faster and stuff like that. And it did happen to be zeros now. But it's uninitialized data. It's just pure happenstance that they are zeros. Well, I really want them to be zeros. So, okay, you can do this. That sets each element of it equal to 0. I mean, yeah, sure, you could put a 90 there and a 100 there and an 80 there, if that's how you wanted to initialize it. I guess let's prove the point and store some 1s in there rather than zeros. And let's put some ENDLs in here so that it doesn't look so dumb. Right, and there's got our 1s as predicted. What happens if you give fewer initializing elements than the length of the array? The array is 5, I'm only filling in 1 of them. So going to fill them all with 1s? No. As many as you specify will get filled in, and then the rest of the array will get filled in with zeros. Well, that's useful because, you know, even if it's 5,000 long, if you fill the first one in with a 0, great, it does that, and then the rest of them automatically are set to 0. So that's nice. Why do you want to do that? Because you don't want non-zero or indeterminate data in your array. You want the, you know, the assurance that if you do print your array out, if you've assigned values to it, it contains good values. And if you haven't assigned values to it, at least they are 0 values. But printing them out like that would be annoying. I don't want to print out 50,000 things like that. Instead, I want to use a loop. No, that's silly. Let's use a loop. I need to know the length of the array in order to do this, right? Because I want to set my counter, start it off as 0. I is my index counter. I want to keep going as long as I is less than 5, but that's cheating, right? Because if later on I go and I change that to 50,000, then I would have to remember to change that one as well. So I'm going to come back and fix that in a minute after I get this working. And so now I'm going to see out both the index number, right? Followed by a space, followed by the array value, tests at subscript I. Just so that we can see, you know, 0 has got a value in it and 1's got a value. We can see those index numbers, which is kind of nice to see. And there they go, right? 0, 1, 2, and 3, and 4. All 5 of those elements are initialized to 0. I need to change the font size on this just a little bit smaller so it stops banging around so much every time I launch it. Maybe that'll help, maybe not. All right, I'm going to comment these out. Don't want it to look like that. What's the next thing to fix? That 5. I don't want to hard code it in there. I don't want magic numbers. Num tests. Well, how do I calculate num tests? Since we are in the same context in which the array is declared, I can use that trick of dividing the size of the array by a size of an int. Right? So int num tests equals size of the array, which is called tests, divided by the size of an int. And now to work, right? No matter how long the test is, now how long the array is, it will adjust it. Because 50 times 4 is 200. The size of test is 200, but divided by 4 bytes per test gets us back to 50. Now that's not a terrible way to do it. See, it printed out 0 to 49. From 0 to 49, to 0 to n minus 1, where n is the length of the array, because, 0 to 49 really is 50 numbers. Probably a better way to, though, is to declare this as a constant. This works. I could do that. And it works just fine as long as I'm in the same pair of braces in which the array was declared. But it won't work elsewhere. Like if I pass this array to a function, I wouldn't be able to check its size in a function. So you'll see a lot of people do it like this. Num tests equals 50. Const int. Num test equals 50. Why are you complaining? Change signature. What are you talking about? Okay, good. The error went away. Or you'll even see people do something like this. Pound define num underscore tests 50, right? And that sets this macro equal to the number 50, so that when the preprocessor runs, it fills in everywhere there's a reference to num tests with that value. Constants are just fine and dandy. I'm just showing you this because you may see that, especially from programmers who started from C rather than C++. They tend to be more fond of macros, I think. That's a generalization. It's probably not true. Anyways, that's one way to do it. You don't have to put that up here inside of here, but that certainly does make that variable available to every function in the code. But normally what people do is they just pass this variable in to the function. So if we need some code that's going to print out the array just like this does, as a matter of fact, I'm going to cut that and I'm going to put it into its own function. Call the function print tests. Doesn't need to return anything, so it's void. Print tests, and it's going to take an array of tests, but it doesn't specify how many there are because it doesn't know in advance. And it's going to have that for loop in there. Now we just need to call it. However, since I declared this below main, I'm going to have to put a prototype for it above main. Fortunately, that's easier than eating cake. I just got to copy that and paste it up here with a semicolon at the end. That's the prototype for it. It lets the compiler know what kind of data the function name accepts and what kind of data it returns, which in this case is none. So now we can call it, but I need to pass in, well, I don't have to, right? Because num tests is declared right here. But what if it hadn't been declared there? What if I'd left it as a constant? Go away. What if I declared it as a constant? It would not be available inside that function. Well, I sure can fix that. Right? I can just pass it in. Int. And I probably wouldn't bring it in with caps, because caps typically mean constants or macros, not parameters. So I would probably lower that to lowercase. Change that to match. And there we go. Or maybe it won't do anything. Let me switch it back to compiling for debug rather than release. Oh, I just never called the function, did I? Anyways, so if I'm going to print it out, print underscore test, passing in the array name, followed by the number of tests, which is num underscore tests, like that. So in the C++ language, unlike a lot of other languages, usually when you pass in an array, you'll also pass in the length of the array so that you can tell your code when to stop. Well, what if we wanted to calculate the total of all those? You would just use a for loop. that initializes a variable to 0 and adds each one in it. Maybe we're done with this and I could delete that completely. Or I'll just leave it as a comment. Let's use a loop and put that loop in a function. So let's calculate the total of it. Calculate the total of the tests. We have to declare an accumulator variable and set it to 0, and then we just iterate through it. So double total equals 0. Same code here, right? However, there's a second kind of syntax. In Python, you may remember that there's a for range loop, and then there's a for value loop. Well, C++ has this kind of loop, and it also has a for each loop. So does Java and C#. And it looks like this. I mean, we could do it both ways just to see the syntax. Sure, why not? Let's do it both ways. Int I is equal to 0, I is less than num underscore tests, semicolon I plus plus, and we're just going to add that value to our total. So we need total plus equals, not plus equals I, because that just adds 0 and 1 and 2 and 3, but tests subscript I. And that'll do it. Now I'm going to demonstrate the same thing with a for each loop. Or total is equal to 0 for every integer in the test. So int, but I'm going to call it v for value. Excuse me, my voice is going. V for value rather than I for index. So for every value in the tests array, add that to the total. All right, so just eyeball these two and see which one you like better. I bet you like that one better. I like that one better anyways. There's a couple drawbacks of doing it that way. One is which this method does not work inside a function because it can't determine the length of the array, right? So it doesn't really know where to stop. If I copied and pasted this code and put it in here, it's just going to yell at me and say that you can't do that inside this function. Going to be an error. I highlight it, and it says, this range-based for statement requires a suitable begin function, and none was found. All righty. Well, I'm not going to even look for what a begin function is, so I'm just going to get rid of that. The for each loop only works inside the context in which the array was allocated. Just like calling size of, like we do here, only works in the context in which we were declared. So this is a way of getting the size. We can get the length of the array by checking the number of bytes and dividing by the element size. But this only works in the same pair of braces that the array is allocated. Same for each. For each is awesome. I like C# because they actually made the keyword for each, so that you had a for loop just like this, and you had a for each loop like this because it had a different meaning. But whatever, we can remember. So the syntax for, and I usually say each integer v in tests. Now the word each is gone. The word in is replaced by the colon, but you know, same thing. For each is awesome, but only works in the same pair of braces in which the array is defined. Anyways, once you get the total, you can print out the total and print out the average if you want. Well, we don't have any good data, right? All we have is zeros. So big whoop. Cout total of tests equals, end quote, less than total, less than ENDL. Cout average of tests equals, end quote. I'm going to be snarky and line those up like that, which is the total divided by num tests, right? Less than ENDL. It's just going to say 0 and 0. Or not. Where's our error list? No issues found. Wonder why didn't it build? Build solution. What? Oh. Print tests does not take 2 arguments. Oh, so you say. That's because I modified it here and I didn't modify the prototype. Java is nice because you don't have to declare prototype for your methods, your functions, no matter what order you declare them. All righty. So the book, as I've mentioned before, would show not filling in these parameter names. Let me show you what that prototype looks like if we don't fill in the parameter variable names. Now, if I go and open a header file and I see this, yeah, maybe I can guess, oh, that's going to be an array of events, and that's probably the size, just because I'm an experienced programmer, and I know that if you pass an array, you better pass in a size. But these names were useful information. So even though the textbook always shows, and I know I've said this, leaving the parameter names out of your prototype, it's just too clever by half, in my opinion. I want all the information that I can preserve about the function so that I know how to use the function when I look at it. Now it should run. Right, so 0, 0, 0, 0, num test is equal to 0, average of test is 0. What other kind of arrays could you have? Well, you could have an array of names, right? Well, what are names? They're strings. I better go and do # include string in a minute. So I want an array of strings of the same length. And I could set them all equal to 0 like this, but all I'm doing is I'm setting their references, the pointers, to 0. It is not a good array at this point. It doesn't have any data in it. And it won't have any data in it until I go through and actually assign some data into it like this. Name subscript 0 is equal to, Joe Bob and stuff like that. Until I do that, there's no good data in it. It's just full of 0 references, null references. And if I try to print them out, I'm even going to get an error most likely. For example, if I try to print out name subscript 1, it's either going to print out the word null or a 0 or throw an exception. I don't recall. Boom, exception thrown. Accessing a null pointer, all zeros. It's just because we just created space for 5 strings, or for references for 5 strings, but we didn't actually construct those strings. Now, sure, this would work. If I change it to 0, we'll print Joe Bob. Stop the debugger. Run the debugger. I thought I changed it. It doesn't like that statement. Okay. Well, we won't initialize it with anything. How about that? Because it was a useless initialization anyways. All right, and so the name is Joe Bob, but if I tried to access any of the others, it would fail. Like if I tried to change this one to a 1, and why are you underlined? See out is ambiguous. No, it's not. Right, it printed out some kind of empty string. That's interesting. What happens if we put a for loop in here to print them all out? For int I equals 0, I is less than num underscore tests, semicolon, I plus plus. Let's see out the integer version of that reference just to see what it looks like. If it'll do this, I'm not sure it will. Test subscript I, followed by a space, followed by that string itself. And I put the arrows the wrong way a minute ago. Test subscript I, subscript, less than ENDL. Let's fix this so that they go the right way. All right, y'all are ticking me off. See out. I don't know what I add that made it decide it needed to do that. Start displaying that error. Oh well, it seems to compile anyway, so. And how could I fix it? I could just put std : in front of it. But usually when that happens, it's because there's a brace placement error. Oh, my using namespace is gone. I know I had it. Apparently I deleted it at some point. Now they go away. But I could have fixed it by doing that. Usually when that error crops up, it's because a closing brace has been missed. And I don't know why it causes that one in particular, but if you're writing your code and suddenly you have 50 errors throughout your code and it's highlighting all those couts where it was not doing so before, usually it's because one of your functions defined above main is missing its closing brace. Okay, so anyways, it's all 0 references. There's no data in it. To fill the data, we could put a loop that would set each one to empty string. I'm going to just steal this for line in the interest of speed and say name subscript I is equal to quote, quote, right? So now there's no data in it. I mean, now it's been initialized. The strings actually have good data.
So, quick question real quick. Now, I don't know if it's just me or not, but do you not have 2 namespaces up there now?
Well, maybe I do.
I'm seeing 2.
Well, yeah, so why did... Is that going to make our couts come back? That's crazy. Yeah, that's great. I went right up there and I added one underneath the other one. And suddenly it started working. I don't know. I need to include string. That's probably one of the problems. Is # include string. I didn't bring in my boilerplate, so I don't have all my things in. So that's going to be a little bit different. Maybe it would have behaved the way I thought. All right, it's still not printing out empties. It's printing out. Oh. That should have been names, right? Thank you for asking that, because that was weird. And I have no explanation for the errors we were seeing. All right, so there we go, right? And if we print out the index number, we'd have a little bit more information to go with. So I could see out the value of I, followed by a space, followed by that. Now that's not strictly necessary, right? It's just for us to understand what we're looking at. You're gonna go away now? Good, there we go. All right, and so we have 4 empty strings, but we could have filled in something else other than empties, right? The word default. Or whatever. Or we could have done this. Let me get rid of that. But let's make a comment as to what we were doing. Initialize array of strings to all empty quotes, right? Zero linked strings. That's what we were doing there. If you know in advance the values, you can do this: string names, num underscore tests, and then fill in the names inside curly braces. Joe Bob, Sam Johnson, Tim Johnson, Wesley Johnson, and Zeke Abrams. That looks weird. Anyways, okay, so we have initialized this array with 5 pieces of data, so when we print them out, we'll see those. And then I go, right? 0, 1, 2, 3, 4, and 0, 1, 2, and 3, 4. And maybe these test scores correspond to these names. Maybe we could ask for the test score Joe Bob and let them fill it in. So we could use a for loop to do that. Please stop telling me to do that. I've already tried and it failed. All right, so we're going to use a for loop to print out the name and then ask for the test score for that person. Same for loop syntax, so why not just copy it? And then so cout, enter test score for less than name subscript I less than colon, just to tell them where to type. And then read that in to the tests at that specific position. We don't need this. There we go, right? Enter the test score for Joe Bob. He made 100. Enter 1 for Sam, right? And there we go. So the total was that, the average of that. These are what are known as parallel arrays. Parallel arrays are arrays of the same length where the data is linked by their index number. Test 0 is for name 0, which is Joe Bob. Test 1 is for name 1, which is Sam. Test 2 is for Tim. Test 3 is for Wesley. And so that's name subscript 3. And then test 4 is for name subscript 4, which is Zeke. So parallel arrays are 2 or more arrays of the same length, right? It wouldn't make do to have more names than we do tests, right? That would be bad. Where the items are linked by their index numbers, subscripts. Oh, look at that, 19% battery, just a sec. And then after we enter all these, maybe we should make a function that would print the test scores out and the name. We already have a print test function, but all it's doing is printing the values out, right? 0, 1, 2, 3, 4, and 5. It'd be better if that function took an array of names as well. So int names, comma, int test. And since I've changed my prototype, I need to go and actually change the function as well. But at least this time I remember to change the prototype. Feeling proud of myself. Going to scroll down here to our function. And so print, what am I doing? Names, except it's an array of strings. Oh, I'm failing on that. Names, and then an array of strings, and then a number of tests. And we don't want to print out I here. I is just the index number. I guess it wouldn't hurt. But what we really care about is the name at that specific position. And let's put a space there as well. And if we brought in the IO manipulators, then we could set the width of each field to make it pretty, right? We could set each one to be 10 columns wide or 20 columns wide or something like that. Build errors. Aha. Since I have a prototype, the compiler knows that this thing actually required 3 parameters, including a number of names. Disappointing. Cannot convert argument 1 from a string to an int. Names, tests, num tests. I don't see a string. Down here, names, tests, num tests. Rebuild all. Failed. Cannot convert argument 1 from string to int. Am I passing them in the opposite order? Names and ints? No. What's the deal, Lucille? Do I have the prototype defined wrong? Oh, yeah, I do. Look at that. That's supposed to be an array of strings. Oh, boy. Okay. So print test needs an array of strings in order to work because names is an array of strings. Excuse me, get rid of that S. And the function itself had better match. And maybe I got it right when I typed that. I did. I just didn't get it right in the prototype. Brilliant. I should just get in the habit of modifying this first and then copying that and pasting it as a prototype. Here we go. Right, and so enter a test score for Joe Bob. He made 100, and 90, and 80, 100, and a 95, right? And now we're printing out our results. 100, 90, 80, 100, 95, right? We've got all that. But let's bring in the IO manipulator so that we can make it look a little bit better. So # include IO manip. That will let me use setW to set the width of each element. Now, in order to do that, I'm going to break this loop up so that it's not so long, right? What do I mean by that? So I can do that. And why am I going to do that? So I can call setW before each one. The index doesn't need to be more than 2 digits wide. Forgot my braces. Unless we're going to have more than 99, right? Now, since it's starting counting at 0, the user might not want to see zeros. They might want to see 1s and 2s and 3s. How could you fix that? Well, you could just add 1 to I as you were printing it out, right? That would make it say 1 through 5 rather than 0 to 4. I'm going to leave it the way it is because we're programmers and we know computers start counting at 0. So I'm going to undo that. Wait. Oh, this is at this point. Right, so now 1, 2, 3, 4, 5. That looks more, you know, legible to human sake. I'm going to change it back, though. If you ever feel like adding 1 to the index value so that you can print them out, you know, on a human 1 through 10 basis rather than 0 through 9, feel free. And so the names, how wide can the names be? Let's set the names equal to 20. And the test score, you know, probably 3 would be enough. Nobody's going to earn more than 999 points on a test. Like that. And it right justified them. I'm not going to even bother fixing that. All right, let's add a couple more comments about what we've done. Let's print the names and index numbers, subscripts, for our names array, just so we can see them. Loop to read or to let the user enter a test score for each name. Print our tests. Print a report of names versus scores. Calculate the total of the tests. That code's fine. This is calculated a total of the tests with a for loop, with an index-based for loop. And here we are calculating the total with a for each loop. Either works. Don't have to do both. Then display the average, right? Display the total in the average. All right, we still got time. Are there any questions for so far? How many of us are here?
Not for me.
All righty. So accessing the array elements, here they have an array of 6 employees and they're asking for the hours worked by each one. And so they just did CIN greater than hours 0, hours 1, hours 2, hours 3, hours 4, hours 5. They didn't even put this in a loop. And furthermore, they're not asking for each input, so the user is just supposed to know that they're supposed to type in 6 numbers in a row. I mean, I guess it tells them for 6 numbers, but anyways, I don't like the way that would look. All it would come up with is enter the hours worked by 6 employees. And then you get a question mark or whatever, you know, the colon, and you were supposed to know that you should type in 6 numbers and then hit enter, or, you know, type in 1 number and hit enter and repeat that 6 times. I like our way of doing it better with a loop. So you can access it with a constant. That's an unnamed constant, which is a literal, right? Or you can use an integer expression. I, or whatever your subscript variable is, has to be an integer. You can't, you know, say test 0.5, right? I don't know what the 1/2 of a test would be. Using a loop to step through the array. Here we have an array size of 5. We've got an array called numbers, and we use a for loop, printing out the numbers of that subscript. And they're using count as their index variable, their loop control variable. I just tend to use I, short for index. So default initialization. If you declare it as a global variable, rather than, I never did get to show that thing having uninitialized bad data, but oh well. Yeah, I did. When I ran it in debug mode and it was showing -8 billion as each value, that's because it was uninitialized data. So if an array is declared locally, the data is uninitialized. If the array is declared globally, the array elements are all initialized to 0 by default. I have no idea why they made that distinction. Kind of boggles me. Why not initialize your local array as well? The only answer that I could come up with is that it does take a finite amount of time. It takes a little bit of time to go in and write zeros into every element of the array. So maybe for speed purposes, they didn't initialize the array. But if that was so important, then why did they do it for the global? Anyways, you can initialize your array with an initialization list, and we've shown that. You can actually be sneaky and just leave that off, and it'll calculate the length based on the size.
Hey, so a quick question. Going back to that previous slide there, it was saying you were thinking that maybe the uninitializing might be faster for it. Is it possible to force an uninitialize on a global array?
No, I don't think so. I do not believe so.
That was it.
Yeah, I mean, that's a very good question, because the compiler, the C compiler itself, has command line switches to either enable optimizations, to disable an optimizations. And so when it creates the kind of the assembly code based on the C code, it'll put little things in to try to make it work more quickly or not. And it seems like that ought to be one of them, right? You know, don't initialize my array, just trust me to do so as I use it. But I don't know of a way of doing that. So when we're looking at this declaration, you can fill it in like I had, or you can leave it out and it'll initialize it exactly to that number of elements. Well, why didn't I just do that in my code? Why did I go ahead and set a size for my parallel arrays? The reason why is because if I ever decided I wanted 10, then I want this array to be allocated out to 10, right? Because they're supposed to be parallel. They're supposed to be of the same length. And so if there are 10 test score slots, there better be 10 named slots, or else when I try to access the 6th and the 7th and the 8th name, it would crash. So not a bad idea to go ahead and stick that size declarator in here, even when you're using an initializer list, and technically the compiler can go ahead and fill it in for you. Here's an array of months: January, February, March, April, May, June, July, August, September, whatever. January has 31 days, February has 28, except for this month. I mean, this year, right? Dates are an annoying thing to have to manage, because like leap years is every 4 years, except every 100 years you skip the leap day, except every 400 years you still skip it. It's bizarre. So anyways, I guess we could just check to see if our number, you know, if our year was evenly divisible by 4, and we could add 1 to February, you know, increase that from 28 to 29, whatever. So we have an array here. And when they're printing it out, notice that they're doing the +1 trick so that it says month 1 has 31 days rather than month 0, right? Because non-programmers would like to see it say month 1 through month 12, not month 0 through month 11. If an array is initialized with fewer values than the size declarator, the rest of them are set to 0. So here we have an array that's supposed to be 7 values long. So it has array elements 0 through 6, but the declaration list only has 4 elements. So it fills in the first 4, and the rest of them are left 0. And that's what we took advantage of here when we said, number of tests, we set the first element to 0, and then the rest of them automatically got set to 0. Not because the first one is set to 0. They all would have been set to 0 even if we had done that. Then the first element would have 998, and then all the succeeding elements would have. So now that we've set this equal to 10, but we've only got 5 names in it, I'm just curious as to how messed up that's going to be. what that looks like. And I don't know in advance the answer. All righty. Yeah. So maybe we should have initialized the list with, you know, unknowns or whatever. I don't even know what we would do to correct for that. Nope. No. So I'm going to set it back to 5. But honestly, in a real program, these names would probably be read from another source, right? You might have a file that contained a list of names, and you'd open it and you'd read in each name into an element of the array, in which case you could have initialized the array beforehand with some values that indicated like no name, so that when it got to 5, it said, you know, unknown name, and 6 is unknown name, or 7 is unknown name, or maybe it just knew to stop. Oh, now I'm on a rabbit hole. What is the value of that array? I want to cast that to an int if I can. I'm not sure I'm going to be able to. So like name subscript 9, cout less than, name subscript 9, less than endl. But what happens if so it's just going to print out kind of a blank there, right? Or not.
You want it to
at
be
all.
string?
Thank you very much. Names is undefined. Well, what did I call it? Oh, I'm above the array declaration. But can we like get the address of that variable using ampersand? Is it going to say that the address is 0? We could use that as an indicator. Nope. Not 0. Are they all? Let's print out the address of every element in the array. Let's use a for loop. And print out the index number, followed by a space, followed by the address of that element of the array, followed by a space, followed by that element itself, followed by NDL. What we will see is that each one of these is 4 bytes apart. No, more than that. To go from F4 to 10, that's a large jump. I can't do that in my head. That's 14 in hexadecimal. No, it's not. Anyways, we can see that each one is a certain space apart. And that these seem to be, okay, well, let's print out the first character of each array, cast as an int. No. Why don't we just stop here? I'm going to stop trying to solve this problem. I'm going to just stop trying to solve this problem. Now, you know it's still nagging at me. What if we checked to see if the element was equal to an empty string or not? So if name subscript I is not equal to empty quote, right? If names subscript I is not equal to that, then we print it out. Not going to do the trick? Nope. That would take some further research. Forget it. Forget it. Forget it. Retreat. All right. The reason I'm kind of stuck on that is because you could initialize a numeric array with a series of values that meant that it had no data in it, right? Because a 0 is a valid test score, but a -1 is not. And so if we filled up the entire numerical array with -1s, then as we process it, we could say if that value is equal to -1, it's not a valid test score, right? But I'm failing to see how to do that with strings using this idea of an initializer list. But I don't have to solve that problem. I don't know why it grabbed me this time when every other time it didn't. Let's just bail on that. So you can have an array of strings, an array of names, right? Let's make up some more parallel arrays. String kids equals, you know, Abby, Bobby, and Timmy. How about Eric, Kyle, and Timmy? We're going to do South Park Kids. All right. And it's yelling at me because I don't have my opening curly brace and closing curly brace, so I'll go back and do that. Come on. Why are you? It's not letting me type in a, okay. A closed curly brace on the same line. Maybe if there's an opening one at the beginning, it will. All right, cool. Now a string of foods that they like. Eric likes pizza. Kyle likes kale. Poor Kyle. And poor Timmy gets cake. There we go. And then their birth dates. Eric was born in June. Kyle was born in August. And Timmy was born in January. Now let's print this information out in the form of a table. And since they're parallel array, they should all be of the same length. Maybe we should have defined that as a constant. Constant int numkids equals 3. And then we could use that in here to ensure, to enforce that all of these are the same length, so I don't make a mistake and put 4 in one of them and 2 in the other and then have it crash. Now for int I is equal to 0, I is less than, remember how much I was bragging about how cool for each loops were? The only problem with for each loops is you don't have an index, right? So you can't use for each loops for parallel arrays. So for each loops don't have an index variable, so are useless for parallel arrays because the items are linked by their index number in a parallel array. And if you don't have a subscript, if you don't have an index, then you're messed up. So I is equal to 0, I is less than numkids, I plus plus. Let's see out the kid's name, but let's set the width All these names are pretty short, so maybe set the width of the names to 10. So kids subscript I. And then let's print out their favorite food. Looks like 10. It also worked for those. Not fools. And then let's print out their birth month. And then an ENDL. And there we go, right? Eric likes pizza in June. Kyle likes kale, August. Timmy likes cake in January. Whatever. I'm not real satisfied with that column. Could call that drinks instead, right? Kyle likes Pepsi. Right? Eric likes Pepsi. Can't think of a drink name that starts with a K's. I'm just going to go with water. And Timmy likes milk. And since each one of these is like 5 or less in length, why don't I just set this to 6 instead? Or I could just skip setting the width entirely, right? I could. It'd be a ragged display, but that'd be okay. And if this information was above the data entry loop, that would be better, so I don't have to do this every time just to see the kids array. Tell you what. We're just going to print out the kid name, and then we're going to say, quote, likes to eat, end quote, right? And replace this with, and to drink, end quote, let it go. Once more with feeling. And I forgot a space, but that's easy to fix, right? I forgot a space there too. Yeah. And now we're good to go. All right, so based on these ideas, create an array of int that is 100 elements long. Fill the array with zeros. That's all you have to do. You can use an initializer list for that. Just don't put 100 zeros like this. That'd be real lame, right? Because what if I said it was 1,000, right? And then create an array called ages that contains 4 integers with the values consecutively of 40, 35, 38, and 19. And then create an array called, I hate to use names again, students, that contains 4 strings with the values of, 4 different student names. You make them up. Write a for loop, index-based, that will print those 100. I didn't give a name here. An array named numbers of type int that is 1,000 long. Tell you what, why make it 1,000 if we're just going to print, zeros? Write it that will print those the number array out, and then write a for each loop, also known as a range-based loop. Technically, the textbook might call it that. That does the same thing. And then write a loop that will print the name and the age using the ages and students array. The arrays are parallel. So ages subscript 0 corresponds to students subscript 0. And I don't care if you make it fancy and use set W and stuff like that, or what. Does that make sense? Does this look doable based on what we have? We'll probably do another parallel array example on Thursday to make sure that the idea is nailed down. I'm expecting that arrays are kind of already in our head because we've seen a couple of examples of them in the past, even though we didn't strictly, jump in and talk about initialization and stuff, I don't think. So does that look doable? Does that look feasible? Alrighty, I hope so. So let's go ahead and stop here unless you have any questions over the material. And please ask them if you do. All right, go make a Dropbox for it.